combustion chamber is the part of an engine in which fuel is burned. Internal combustion engine. The combustion process increases the internal energy of a gas, which translates into an increase in temperature, pressure, or volume depending on the configuration. In an enclosure, for example the cylinder of a reciprocating engine, the volume is controlled and the combustion creates an increase in pressure. In a continuous flow system, for example a jet engine combustor, the pressure is controlled and the combustion creates an increase in volume. This increase in pressure or volume can be used to do work, for example, to move a piston on a crankshaft or a turbine disc in a gas turbine. If the gas velocity changes, thrust is produced, such as in the nozzle of a rocket engine. Petrol or gasoline engine. A petrol engine is often designed so that the moving pistons are flush with the top of the cylinder block at top dead center. The combustion chamber is recessed in the cylinder head and commonly contains a single intake valve and a single exhaust valve. Some engines use a dished piston and in this case the combustion chamber can be considered as partly within the cylinder. Head types. Various shapes of combustion chamber have been used, such as L-head for side valve engines, bathtub, hemispherical, and wedge for overhead valve engines, and pent roof for engines having 3, 4 or 5 valves per cylinder. The shape of the chamber has a marked effect on power output, efficiency and emissions. The designer's objectives are to burn all of the mixture as completely as possible while avoiding excessive temperatures. This is best achieved with a compact rather than elongated chamber. Swirl. The intake valve port is usually placed to give the mixture a pronounced swirl above the rising piston, improving mixing and combustion. The shape of the piston top also affects the amount of swirl. Flame front. Finally, the spark plug must be situated in a position from which the flame front can reach all parts of the chamber at the desired point, usually around 15 degrees after top dead center. It is strongly desirable to avoid narrow crevices where stagnant end gas can become trapped, as this tends to detonate violently after the main charge, adding little useful work and potentially damaging the engine. Also, the residual gases displace room for fresh air-fuel mixture and will thus reduce the power potential of each firing stroke. Diesel engine. Diesel engines fall into two broad classes: direct injection, where the combustion chamber consists of a dished piston; indirect injection, where the combustion chamber is in the cylinder head. Direct injection engines usually give better fuel economy, but indirect injection engines can use a lower grade of fuel. Harry Ricardo was prominent in developing combustion chambers for diesel engines, the best known being the Ricardo Comet. Gas turbine. The combustion chamber in gas turbines and jet engines is called the combustor. The combustor is fed with high-pressure air by the compression system, adds fuel and burns the mix and feeds the hot, high-pressure exhaust into the turbine components of the engine or out the exhaust nozzle. Different types of combustors exist, mainly, can type. Can combustors are self-contained cylindrical combustion chambers. Each can has its own fuel injector, liner, interconnectors, casing. Each can get an air source from individual opening. Cannula type. Like the can-type combustor, canannular combustors have discrete combustion zones contained in separate liners with their own fuel injectors. Unlike the can combustor, all the combustion zones share a common air casing. Annular type. Annular combustors do away with the separate combustion zones and simply have a continuous liner and casing in a ring. Rocket engine. Steam engine. The term combustion chamber is also used to refer to an additional space between the firebox and boiler in a steam locomotive. This space is used to allow further combustion of the fuel, providing greater heat to the boiler. Large steam locomotives usually have a combustion chamber in their boiler to allow the use of shorter fire tubes. This is because, long fire tubes have a theoretical advantage in providing a large heating surface, but, beyond a certain length, this is subject to diminishing returns. Very long fire tubes are prone to sagging in the middle. Microcombustion chambers. Microcombustion chambers are the devices in which combustion happens at a very small volume, due to which surface-to-volume ratio increases, which plays a vital role in stabilizing the flame. See also, cylinder head, engine displacement, combustor, Variable compression ratio, references.